It's another session of geography. You're welcome. Today we are looking at soil. Soil, this is a product of weathering, a product of rocks being broken up. It's what we are seeing all over our places, especially here in Africa, where paving is less. That almost everywhere we see, everywhere we look, we are seeing soil. There's a definition there. That's the upper layer of the earth crust on which plants grow. Definitely. Without soil, I think it will be the greatest misery of the world. So it's these soils that support plant life. What makes up soil? What we are calling soil constituents. What is in that material, those surface material that supports plant life? There is organic material, or that is organic matter. We have inorganic matter. We have soil water, at times we call it soil moisture. Then we have air. There is air in that soil. We are looking at soil. So let's look at these constituents one after the other, starting with inorganic matter. We are saying this inorganic matter is weathered rock fragments from the parent rock, those materials that broke off from the rock. And they are saying forms skeletal or fabric of the soil. So it is when we say skeletal or the fabric, we could say the raw material. The raw material, how the soil comes from this inorganic matter. And they're saying that 45% of the soil is from these weathered rock fragments. Then the organic. They're saying these are decomposed materials of animals and plants. These organic. And they are the ones that form 5%. How are they significant? That once broken down, they form humus, which improves the fertility of the soil. That soil with high organic matter is alkaline, while those with low organic matter is acidic. And I will tell you, the soils which are alkaline are the most sought after. It's soil that we are looking at. Another important component is soil water. Maybe also to inform you, the soil water, more than 90% of it comes from precipitation, or what we call rain. They're saying water contained in the soil, that's what we are calling soil water. The other time we would say soil moisture. And it forms 25% of the volume of soil. What's the importance? That it acts as a solvent of minerals and nutrients. So when we say solvent, it is the one used in mixing air. Then causes leaching of materials. Leaching. That these materials or minerals are moved from the upper layers downwards. So the upper layers might be that much enriched. So with this soil water, these materials can be moved from the upper layers to the bottom layer, so that there is equal distribution. We are looking at components of the soil one after the other. That soil water causes waterlogging, which blocks air saturation, causing soil to lack oxygen and become acidic. Remember, in importance, there is positive and negative. That again, it is this very soil water, which when it is in excess, that's when you use the word logging, it blocks air saturation. And once air saturation is blocked, then these soils will become acidic. Then we have soil air. So they are saying soil contains air within its what we call pores. there are spaces in between the soil particles. So within these spaces, there is air, and it accounts for 25%. And what is the importance of this air? That for plants and soil organisms, metabolism is process of these organisms carrying on with their life activities. They need air, like we also need air for breathing in, or for oxygen to carry on with our body activities. So even these organisms in the soils, they need this air for their living, if to put it in a few words. That for oxidation, which causes conversion of part of organic material into nitrogen, that nitrogen is also quite important. So in that process, air is needed. Definitely there, that will be oxygen. So it's part of that air. Then for respiration of aerobic microorganisms, which break down organic matter to form humus. These at times we just use the word bacteria. If they are to survive in these soils, this air has to be there. And the importance of these bacteria is they are the ones that help in the decomposition of the organic matter, or the decomposition of materials into organic matter, which organic matter is quite important for plant growth. Let's look at soil formation, starting with the factors influencing soil forming processes. That for us to have soil, what has to be put in consideration? We're starting with the rock, and we are saying the parent rock, the original rock, that determines the type of soil, mineral composition, and texture. That what type of soil it will be, what minerals will be there, and what is its texture going to be like will depend on the rock which was there. They are giving examples that if a rock was granite or sandstone, these ones will weather what you call sandy soils, which have a lot of quartz. Then if it is what you call volcanic lavas, they will form clay soils with low quartz. The one of sandstone have high quartz. Then the ones of volcanic lava, they have less. And the plants decompose to form loam soils in humus. But what is important there is what rock was there is very important in determining the soil that will form in that area. That's the gist of the point. Then climate. That areas with the heavy rainfall are going to have deeply weathered soils. Because you know how much water plays in breaking down of the rocks. Then from there, the distribution of minerals from top to bottom in that process of leaching. So the more the water in an area, the higher the rate of soil formation. So desert areas, definitely they will have those what you call the rice soils. They are very deficient in nutrients. Because water which would have distributed, or water which would have helped in decomposition, is lacking in the desert areas. Wow. Then we look at living organisms. You have the microorganisms that we've been talking about, how they help in decomposition of these plant materials. So if they are to help in decomposition, you know how this one will enrich the soils. Then we have the burrowing animals. These burrowing animals dig it too. They mix. Then with the living organisms, we end with the roots. That the roots penetrate these areas or the rocks definitely a lot will grow where there is an initial small crack. So in the process, this root will be widening the crack. So once it is widened, more factors will play here after the root widening the crack. Then topography. Topography, they are saying that there is maximum soil development in rolling and well-drained uplands. This is about the landscape. The rate of erosion matches with that of soil erosion. When we say rolling, at times we use it for gentle. But if areas which are steep will have immature soils due to severe erosion, because for us when you're talking about soil formation, we are looking at this rock being in place for some time. We always use the word in situ. So if a rock has started cracking, then eventually, because of the steep slope, it is lost to another place. It flows to another place, then the process will be affected that way. Time. The longer it takes, the better the soils or the deeper the soils will have. Weathering is a gradual process. That is soil formation. So the longer a rock takes in a place with all those factors acting upon it, definitely the deeper the soils will have in that area. So time is also another important aspect. Soil forming processes, where we have the first process we call weathering, where rocks are broken down to form rock particles. From there, we have the decomposition of organic matter, because the rock materials alone cannot form soil. So now we have other materials to add up. Remember we said these ones make the rock material make up 45%. Then we are having the 25% from this organic material. We're starting with mineralization, where we have biological and chemical breakdown of plant tissues by the bacteria. There we have substances added onto the soil when these plant materials are broken down under what we call mineralization. Humification, we are saying regrouping of mineralized dead plant and dead plant material into large molecules to form humus. Now the decomposition is taking place in humification. Then leaching, we said distribution, that minerals that have been formed from one level are lost into the other. In fact, it's from top to bottom. Leaching, remember we are seeing soil forming. And they are given types of leaching there. We are moving where we have what we call lateralization, that moving in a solution or in a suspension of weathered material from horizon A to B. So the red soils form in A after minerals have been lost through leaching. That's why we have them called laterites in the process lateralization. We have irradiation, that these materials, after they have been lost from the upper parts, they accumulate into layer B, what you call horizon B. That is irradiation. Leaching, they are lost, then irradiation, they accumulate. And this one happens, they are saying hard soil masses, hard pan results. There's now much accumulation of these materials. Then aeration, that mechanical washing down of fine particles in suspension from the upper layer to lower levels, or lower layers, so by water. That what had been irradiated is also further again lost, water acting upon it. Note the word final mineral materials in suspension from upper layer downwards. And they are giving example of clay. Podosolization. This is a heavy depression of horizon A of all minerals, especially bases and ions, by soluble organic substances. Whenever I say soluble, this is dissolving agents. That heavy depression. And at the end of the day, forms ash-like soils which are acidic when there has been heavy depression of horizon A of all the minerals, especially ions and bases. There is calcification. Remember, we are looking at soil forming processes. Limited leaching, which allows redeposition of calcium components or compounds within the same soil profile. That there is limited leaching. So when it is limited, there will be accumulation of calcium in this level of the soil. So calcification comes from corrosion, or calcium is born as a result of calcification process. There is what we call rebification, the hydration of soils during dry season and leaching during the rainy season. That during the dry season, definitely you know how the soils become dried up. And during the rainy season, again the minerals are lost downwards. What has been a pleasure having you. We love you. Have a nice time. God bless you.